This video is to help you build phylogenetic trees. So if you're on the website, go from, here we go, 1B, go all the way to the bottom where it says practice. And this first resource is the one that I'm using. I would highly recommend using it because it is a great way to learn how to do these. Great, so we are going to start with mission 1, building a tree. I'm going to replay this. So when building a tree, we're going to go ahead and drag and drop our two organisms. So we need to determine where this trait should go. If we place it here, let me put that up here, we're signifying that only the gecko is going to receive that trait. If we place it here, we're signifying that only the palm tree is going to receive that trait. If we place it in the center, we're signifying that it's going to go to both of the traits because the trait has been placed before this divergence. So that's a really simple one. So let's go ahead and start with a little bit more complex one. Here's our fly agaric. Come on. Oh, I have to click on it first. Yay. Okay. So we can read about it here. And what that's going to do is that's going to give us information about this particular organism. So I can do one of two things. I can either go ahead and just assume that it's going to be on one side and use the traits to test out, or I can read about it. So let's go ahead and read about it. So I can see, okay, so it has cells with nuclei and is heterotrophic, okay, which means it obtains nutrients by consuming other organisms. Well, now let's explore some of these other ones. The palm tree also has cells with nuclei, but it's actually photosynthetic. Let's look at the gecko. The gecko is cells with nuclei and is heterotrophic. So by reading that, we actually find out that the fly agaric is actually closer to the gecko because they're both heterotrophic. You would normally assume that it's closer to the palm tree because you would assume that it's photosynthetic. So now I'm going to take my traits and I'm going to place them on here. Photosynthetic autotroph. If I placed it down here, it's going to go to all three, but we know that's not the case. So I need to place it after this divergence to signify that it's only going to the palm tree. But both of these are heterotrophic, so I'm going to go ahead and place it once again before the divergence to show that it goes to both of these. Now we've completed our first puzzle. Is an animal or plant more closely related to the fungus? Well, we probably would have thought plant first, but now as we really look at it and realize those trait similarities, we realize that it's actually the animal. Let's go to a little bit more complex one. So here are our three traits: amniote, vertebrate, or bilateral symmetry. So let's look at our dog. Okay, amniote, vertebrate, bilateral symmetry. Goldfish, vertebrate, so it is supported by a single backbone, bilateral symmetry. Amniote, vertebrate, bilateral symmetry, and only bilateral symmetry. So I would definitely be taking notes on this and start organizing everything. I like to start with the one that's the least common from everything else and build it from there. So let's look. Okay, king snake has those three, only two, and then three. So I'm going to go with the one that is now least like these other two. So that's going to be my goldfish. Okay, so I do know that they were both, which trait did this one have? Bilateral symmetry. So they both share bilateral symmetry. Let's check. Okay, so we're good. Now I need to go with my other traits. Okay, let's look at king snake. Okay, that's got all three, and that has all three. So I'm going to place those up here. Okay, so we're still good. And dog. So there's a lot of places you can put the dog. You can put it next to goldfish, king snake, down below. Because they both share three, I'm going to put it next to king snake. All right, let's look. Goldfish also had vertebrate and bilateral symmetry. So I'm going to put vertebrate down here because I know that all three of these have vertebrae. All right, let's check it out. And we're good. Now my last trait is amniote, and I know that it goes to only these two, so I'm going to place it before the divergence, but after this one here. And there we go. The animals in this puzzle look very different, but they all have one thing in common. What trait is that? Well, let's go to the one that's very, very first here because we're showing that that goes everywhere, which is they all have bilateral symmetry. Okay, so from here you can go on to much more complex things to read about all of these, and you can build fairly complicated phylogenetic trees. I would recommend, let me go back, let me see if I can go home, here we go. I would recommend at least getting through this DNA one, so go through mission 1, mission 2, and mission 3, because at mission 3 it shows you how to use DNA as evidence. Am I in the right one? Oh, here we go. Which, as you can see, is part of one of the things that we have to look at. So we used organism traits, but we also need to learn how to do DNA. It's going to be very similar, though, to the one that I just showed you. But they're both really helpful, so I'd recommend going through all of those. And in class next week, we will do some practice problems in which I give you a chart that has those traits, and you'll be able to build it from there. But I think using NOVA is a great start for this week.